Under a technical point of view, energy modeling is a mathematical and decision-making process that falls in operational research. Operational research is a discipline that relies on mathematical modeling and optimization to support supply chain strategy decision-making in situations of scarcity of resources. Originally conceived for industrial project management, it finds a perfect application in the field of energy planning and strategy. Operational research follows 6 steps that, once adapted to energy modeling, are as follows. Definition of the problem of interest and collection of relevant data. Formulation of a mathematical model to present the problem. Development of a computer-based procedure for deriving solutions. Test of the model and refinement when needed. Preparation of the application of the model. Analysis of the results and advocacy towards policymakers. Step 1. Define the problem of interest and collect relevant data consists in understanding what is the objective of the analysis, what is the geographical scope, what is the kind of policy recommendation we are looking for, or which kind of strategy we are aiming to define. In practical terms, some questions are to be asked. Are we assessing the impact of a national level policy in the next decades? Are we evaluating the optimal dispatch today given a certain asset of power plants? Do we need to size rural microgrids? This step is fundamental to identify the kind of model we need to build, and all the relevant data to characterize the problem need to be collected. Step 2 is formulating a mathematical model to represent the problem. This means transforming our real problem into a mathematical structure, identifying all the equations that govern the phenomena under study. When designing such equations, 2 main constraints need to be taken into account: data availability and computational complexity of the model, in order to ensure the feasibility and the quality of the results. In most of the cases, when we adopt an existing model, this step has already been completed by the developers. Therefore, our task is to ensure that the equations fit with our needs, or when necessary, be able to design the expansion or adaptation of the model to our constraints. The equations developed in step 2 are translated into computer language in step 3. Development of a computer-based procedure for deriving solutions. Also in this case, a large variety of existing models has been developed to answer to many research questions. The choice is left to the analyst to build a new model to fit their needs, or to choose from the existing ones and eventually expand them. Once the model is built, it is possible to proceed with step 4. Test the model and refine it as needed. At this stage, it is possible to test the robustness of the model to verify if the work done so far is consistent and the model is so able to support the decision-making process. At this stage, different kinds of tests can be carried out. Verification, to ensure that the program solves the equations correctly. Validation, a procedure to test the extent to which the model represents the reality. Sensitivity analysis, a procedure to assess how the model is reacting to the variation of input parameters. Step 5. Prepare for the application of the model. Consists in the actual application of the model built or selected to the original problem, inserting all the input parameters, defining the structure of the reference energy system, and run the final optimization in order to identify the proposed solution to the problem. Step 6, the final step, analyze the results and inform policymakers. Even if it might seem like a mere consultation of the results, it's the step where the engineering thinking is strongly required. The model will produce a set of results depending on the model, ranging from the installed power of different producing technologies to the produced energy from each technology. It's then the duty of the analyst to properly interpret such results, understand their range of validity and significance, and properly translate them into recommendation for the decision makers to inform future policy with scientifically sound, evidence-based results.